תודה רבה, יונתן. עכשיו יש לנו כסף, אנחנו צריכים תמיכה אקדמית. אז דני בלומברג, שהוא סגן נשיאה למחקר ופיתוח באוניברסיטת בן-גוריון, ואני אקצר בהקדמות דני כי כבר ארוחת צהריים מתקררת, דני ייתן לנו על קשרי אקדמיה ויזמות. בבקשה, דני.
Good morning and welcome. Just let me find the... Okay. Good morning, welcome. It's a pleasure to be here. Ofer gave me a hard task this morning. He asked me to give 2 talks, which I could give for 2 hours each, and do that in about 9 minutes. And the 2 issues are, one is academia-industry relationship, and the other is BGU-SAT, a new Israeli satellite, which was launched in February this year, and talk about that also. So I have to combine the 2 somehow. So I'm going to use BGU-SAT as an example and talk a little bit about industry-academia relationships, something that's under my auspices within the university as VP for Research and Development. There are a few names mentioned here on the first slide. Dr. Shimrit Maman, who's sitting over here, from my lab, a researcher involved in BGU-SAT. Aviran Sadon, a student-to-be doctor, I think that is here somewhere in the audience. And IAI MBT, I didn't mention names because the list would be too long to put on the slide, but many people at IAI MBT are partners in this endeavor called BGU-SAT. Now, to Jonathan, who just spoke before me, he was introduced as someone who makes money. Well, I promise you, we know how to spend money in academia. That's our job. By the way, BGU, we're partners in JVP Cyber Labs, so we know how to play both sides also at the same time. Yeah, and thumbs up to Jonathan. But can I get the slides to work? Now it's working. Okay. When we talk about academic-industry relationships, we're talking about 2 very different environments, 2 very different cultures, and I think that that's where the key issue is. In academia, we tend to talk about basic science, although there is a change in the discourse. You can hear more and more discussion about relevant research, more and more accountability in research. We talk about long-term research or long-term return on investment, whereas in the industry you always talk about something that's applied, something that can be sold in a very short time. You talk about very short return on investment. In academia, we tend to work individually as individuals at the most with our students in the lab, whereas in industry, you always look for partnerships, you always look for collaborations. In academia, we get judged by publications, where we publish, and the quality and quantity of publications, whereas in industry, you tend to keep everything close to your heart, close to the chest, and you don't want to publish the heart of what you're doing. Another thing that I should say, in industry, you have to succeed, otherwise you're out of business. In academia, failure often is success. If we prove that something doesn't work, to us that's success, and that you have to remember always is in industry, because we can do certain research which you cannot do and still consider it something that was successful. The roadblock in collaboration between academia and industry is always intellectual property, and that's where the lawyers always fight and argue, and all the hand wrestling and everything goes on. But the real difference is in the culture. Once we get over the other issues that I just mentioned, I think that IP can be resolved, because in the end, we always want to do something that does good and that produces intellectual property, something we both want. And if we both want it, when you have people that want to work together, they're going to work together. And as I said, I'm going to use one platform which was worked on together between Ben-Gurion University of the Negev in Beersheba, and IAI, that's the Israel aerospace industry, the MBT division. BGUSat is a small CubeSat, it's a 3U, 30 centimeters by 10 by 10. It's a technology demonstration. The idea was to see what we can be doing with CubeSats, try and test imaging systems, understand orbit, altitude control, and so on. It's an education platform to bring students into satellite engineering and space engineering, provide hands-on experience, and a platform for industry academia collaboration. And not all the collaboration actually goes into that small platform, which is the size of a milk box. A lot of that produced new collaborations which will be seen in the long term and not only in the short term. As I said earlier, we do long-term research in academia, whereas the industry looks mainly at the short term. And I apologize for drinking tea so that I don't lose my voice as I go along. When we talk about CubeSats, they're a platform that was designed for academic research and for academic ability to go into space research. But at the same time, it's obvious that it's much cheaper, and there's a lot of potential for industry also in using CubeSats if the silver bullets can be found, and if we show that there are potentials for this kind of collaboration. So when we talk about academic issues, we wanted to see what the CubeSats can provide in terms of earth sciences, for example, atmospheric sciences, and so on. In terms of industry, the questions are related to miniaturization, reduction in cost, altitude and orbit control in very small satellites. In terms of academia, we want to see what the limitations are to science when using these very small satellites. In terms of the industry, again, how do we reduce the cost? How do we launch at the same time many of these satellites and keep track of all of them and control them? And there are many other issues that can come along these two sides of the slide that I just showed you. BGUSat, I said, is a 3U satellite. It's a very small one, launched February 15 this year from India. And in the past 4 years, students at BGU have been involved with IAI-MBT engineers in making sure that this launch will take place and will take place successfully. Several interdisciplinary projects were developed from this in many areas: computer science, mechanical engineering, geosciences, and so on. Satellite was launched on the PSLV C-37 February 15, together with another 103 satellites. The main payload was Cartosat, which is an Indian satellite, and you can see here one of the images acquired by Cartosat, high-resolution image for cartographic purposes. But we also had BGUSat with a camera in the shortwave infrared, which can allow us to do several things, including separation between ice clouds and water clouds. It can see forest fires, and Arizona is somehow close to my heart as an alum of ASU. And you can see a forest fire here in this one image taken by this very little small satellite, which is in orbit at the moment. You can see that fire over there. I hope you can see it on the screen also. I'm going to skip the technical characteristics. And you can see over here a comparison between two images. One taken from this very small satellite, which is only a little bigger than this bottle of water that I'm holding in my hand. And the other is from a NOAA AVHRR satellite, which is the size of a, not a semi-trailer, but it's a big satellite, a much heavier satellite, much more expensive. And obviously you can see the difference between the two. Whoop, what did that do? Okay, somehow I was trying to point over there, to use a pointer. But the slide on the right is from NOAA AVHRR, which does have several bands on it. It costs much, much more than this tiny satellite. And the slide on the left is from BGUSat with a better resolution, better quality image. And one can think, for example, of having several BGUSats in space doing the same work that that satellite could do. Am I going backwards now? Yeah, it's going backwards. I have no idea what this thing is doing. There we go. And this slide over here shows you a slide that I think was also shown yesterday. It's a movie before and after, or actually during and after, the last storm that we had in Israel last week. And you can see the clouds evolve over Israel. And there you go. You can see on your left side, Israel without clouds. On the right side, Israel with clouds. And you can see what can be done from this miniature satellite. And we can even drape an image of Israel over the DEM and do scientific work, in this case, in the shortwave infrared, studying geosciences, atmospheric sciences, and so on. We've so far collected over 3,000 images, and we're beginning to do the scientific work, complete the calibration, and it just goes to show you that, first of all, there has to be interest on both sides, industry and academia, and that's all about people. We have to know how to put the lawyers aside so that the intellectual property doesn't become the only obstacle and the main obstacle and kills the project. And in the end, if you understand each other's needs in the project, you can make it happen with, and I'm looking over here at Avi, with governmental support. I think that that's a key issue also. And thank you. I'll end here.